In Isotopia, we are going to discuss and learn what isotopes of an element are stable, what isotopes aren't stable, and which isotopes are radioactive. So, by the end of this, we should be able to read and interpret the isotope graph. We should be able to tell how many isotopes of a substance there are based on the graph. We should review isotope notation, which we did in the warm-up. So we should know that different isotopes are the same element with a different number of neutrons. We should also be able to figure out which isotopes are radioactive and which ones are stable. Moving forward, an element is defined by the number of protons in the nucleus. We've talked about this extensively, indicated by the atomic number. So the atomic number, remember, is the whole number in the periodic table.
Let's write that.
For every carbon, it has 6 atoms. For every carbon, it has 6 protons.
Can you write this?
If you guys need to take this down, 1. So we look at nitrogen. Every nitrogen atom has 7 protons. Every boron atom has 5 protons. Okay? That's what defines the element. Every atom with 5 protons is boron. Every atom with 6 protons is carbon. And every atom with 7 protons has to be nitrogen. It's what defines the atom. So this is a little thing, little cartoon I'll let you guys take a look at in a second. So essentially all of these nuclei are held together. The protons and the neutrons are inside the nucleus, and they're held together with what we call the strong nuclear force, which just pulls the electrons together. Pulls the protons together in the nucleus, and that's what an atom is. And then when the electrons are in the electron field, and those nuclei surrounded by electrons are responsible for all the cycles on the planet. So there's a fun little cartoon you guys can take a look at later.
Are we smelling the poop or are we smelling the flies?
Shh. Moving on. So, for instance, we have a couple different types of carbon. There are carbon 13 and carbon 14, as well as carbon 12. These are isotopes of carbon. They're the same atom, same element, but with a different mass. But they're both carbon because they all have 6 protons. They just have different numbers of neutrons. Okay? Does that make sense? So, the different percentages, they're called abundances, and that's how we talk about the atomic mass, the average atomic mass. And why carbon is closest to 12 is because about 99% of carbon atoms are carbon 12. So we expect the average to be close to that. So our isotope notation, we talked about this. This is just review. So we have each of these is an isotope of carbon. It's just a shorthand way of writing the element. So moving forward, can you just stop that? It's distracting.
It just broke.
I know. Shh.
It's gone now.
Okay. So remember, mass number up top left-hand corner for each isotope. So they're all carbons. They all have 6 protons, different number of neutrons. That's why they have their different mass numbers. And this is another review. Slide. 17 protons. We must have 37 total protons and neutrons because that's my mass number. Notice the mass number doesn't even have to be close to the atomic mass. So this is the mass number for chlorine 37 is 1.5 AMU off, and that's fine because the atomic mass is not on the periodic table. The mass number is not in the periodic table. So not all isotopes are stable. Only certain ones actually form. So like carbon 12 forms, but never carbon 11. Some elements have one isotope, like fluorine. There's only fluorine-19. Some isotopes are radioactive. They only exist for a certain amount of time, and then they break apart. So how can we figure out which ones form? We can figure out which isotopes form based on this graph. So take this out, this graph, and look at it on your thing. So each box represents an isotope of a given element. If you look on the horizontal axis right here, it's the number of protons. And we talked about that's what defines the element. So look at hydrogen, atomic number 1, which has 1 protons. We can look here. We have hydrogen with 0 neutrons. We have hydrogen with 1 neutron and hydrogen with 2 neutrons, all of which have the atomic number 1 and have 1 proton. So there are 3 isotopes of hydrogen. Hydrogen 1, hydrogen 2, hydrogen 3. The isotope refers to the mass number. Okay, so hydrogen 3 has a mass number of 1 plus 2 for 1 proton and 2 neutrons, like we've been talking about. Helium only has 1 isotope. It only exists with 2 protons and 2 neutrons. So I want you guys to take a second and fill in these other boxes over here. So, right? So we look at Li. We figure out helium in Li. Helium only has 1 isotope, and that's helium with 2 protons and 2 neutrons. So that's why it's helium-4. That's the only isotope of helium. How many isotopes does lithium have, Rafi?
Wait, but
No?
3.
No, that's the atomic number. How many isotopes? How many boxes for lithium? 2. Lithium has 2 isotopes. How many isotopes for carbon, Minnie?
carbon?
Yep.
3.
Yep, 3. 12, 13, and 14. Okay, so you guys can figure out how many isotopes. Each box represents 1 single isotope. So this graph right here is this graph that we just looked at, but instead of up to 6, we have all of them. We have a lot more. It's almost the whole periodic table. So you can tell the number of isotopes by the number of boxes in an element. So for instance, atomic number 40, you go up to there and you see it has one solid shaded in box. So look, take this graph out and look at it with me. Back in the shot. Okay, so take this out right now. So you look at atomic number 40. 40, there's 1 shaded in box. Stop leaning back in your chair, Chris. Don't want to have to ask you again. So that atomic number 40 has 40 protons. So that is zirconium. Zirconium has 1, 2, 3, 4, 5 boxes. That means there are 5 isotopes of zirconium.
Yay.
So the most abundant one, if you look at the key down here, is the one that's shaded in. So, 1 second. So the shaded in isotope, the most abundant one, that means the one that there's most of, has 40 protons and 50 neutrons. So what the mass number would be what? 90. Great, Chris. So that would be zirconium 90. So other isotopes, you look above that, is Zr with 51 protons and 52. Those are 2 isotopes that exist, but that are not as abundant. So we also look up here, and there's one at 54 and 56 neutrons. So zirconium 104 and zirconium 94 and zirconium 96. Those are what we call radioactive isotopes. It's an element, it's a metal. And those are radioactive isotopes that aren't stable all the time. They'll break apart. We're going to talk about that